Hi, it's Mrs. Mallet, and today we're going to talk about scientific notation. Now, notice right here underneath my title, I have this formula, I guess you can call it, for scientific notation. That's the standard form of how you write scientific notation. A stands for your, what I like to call your base number, um, and then the x means times. So A is your base number, the x means times 10 to the, and the r is your exponent. Now your r is how many times you're going to move your decimal over. Okay, so let's do this one with my first example here, the 367 million number. So first of all, you know that your decimal is at the end. It's right here. That's where your decimal is. Now what we want to get our A, or what I like to call our base number, you want to move your decimal in between to get a number that's between 1 and 10. So for example, if I were to move my decimal right here, and I'm looking at 36.7, is that between 1 and 10? No, it's not. So you want to move your decimal until you get a number that's between 1 and 10. I erased my 6 and write it back. Okay, so if I move my decimal here in between my 3 and 6, do I now have a number that's between 1 and 10? I do. So now we have 3.67. So we always have our x times 10 to the, and let's look at our number. Let's count how many times did I move from right here originally to in between the 3 and the 6. Let's count. 1, 2, 3, 4, 5, 6, 7, 8. I moved 8 spaces. Alright, so that's going to be our exponent. I moved 8 spaces. Okay, so now let's do my bottom example, that decimal. First, let's get our A. Let's get our base number. You want to move your decimal to a number that's between 1 and 10. So I'm going to move it right here in between the 2 and the 5. And I have 2.54. So I have 2.54 times 10 to the. Now let's count how many times I've moved my decimal over from here to there. So that's 1, 2, 3, 4, 5. I moved my decimal over 5 spaces. Okay, now this is going to be -5. And now let me explain to you my reasoning behind that. Look at the 367 million number. Why was that a positive 8 versus this 0.000254 number? Why was that a -5 exponent? Well, when you look at this, I like to think of this with money. If you look at the 367 million number, wouldn't that make you happy if you had that much in your bank account? It sure would make me happy. So, because it makes you happy, it'll be more positive, hensing the positive 8 exponent. Now look at the 0.000254 number. Would you want to have that much in your bank account? That's not even a penny. That's like less of a penny. It's not even worth anything. That would make me very sad and very negative. So whenever you see a decimal number, that would make you very negative and very sad because I wouldn't want to have that much money in my bank account either. So that's why you're going to have the negative exponent. Okay, so anytime you have a big number, when you count over, it'll be a positive. Anytime you have a decimal number, when you count over, it'll be a negative. So let's try some more. Okay, so let's say that I have 0.0043. Let's write that in scientific notation. Okay, so let's get our base number. Our base number is going to be 4.3 because that's the number between 1 and 10. And how many times did I move over from my original decimal spot to in between 4 and 3? I moved over 1, 2, 3 spaces. So now, is it going to be a -3 or a +3? Look at the original number. The original number is a decimal. That means it's going to be a -3. Okay, so now let's say I have this number. Okay, so let's move our decimal in between the number that's between 1 and 10. So we'd have to move it right there to get 2.05. Let's count how many times we moved our decimal over. We moved it 1, 2, 3, 4, 5. And it'd be a +5 because originally you would want to have $205,000. I know I sure would. So this is how you write a number into scientific notation.